Hey everyone, we are here again to try to repair this third Commodore 64 board of my good friend Tony. This one is just marked like black screen. So let's power on and see what happens. Yeah, indeed, black screen forever. Okay, so we are going to check some things and see what we find. Of course, this time our nice friend PLA would be one of the first things we'll check. So let's see what happens. Okay, so first test, clock generation. Both clock seems okay, stable, and I'm in phase. Dot clock seems a bit noisy, but looks good. Fair enough for now. Color clock frequency, it's okay. 17.73447, more or less, but better than this is really tricky. So okay, let's go on. Okay, black screen, maybe, well, almost anything. We excluded the clock generation and VIC chip. We can exclude, of course, the SID. This is one that's working because I transplanted it on a previous repair and it works. It can be the CPU, it can be the PLA, it can be kernel ROM or basic ROM. Might be also one of the CIA, but that's quite unlikely. Not the first thing one thinks of about anyway. It can be RAM, decoding logic, so we have to probe around. I scoped the CPU clock and it's okay. I scoped the reset signal and it's okay. I checked the PLA and it seems okay. It has inputs and outputs at the right level. Of course, the CPU is not executing the correct addresses. That's because it is not reading correctly. That means because the PLA is not decoding correctly, but we can tell easily at the stage. It can be because the RAM is faulty or the decoding logic of the RAM itself can be faulty. So first thing to check, in my opinion, in this case is U13, this one, and U25, this one. These two chips are they serve a precise purpose. They get the addresses from the CPU and they multiplex the addresses to the RAM chips. So basically these two chips takes the full addresses from the CPU and send the addresses, the column addresses, to the RAM when the column address strobe is sent, and the row addresses to the RAM when the row address strobe is sent. So let's check the output to the RAM of these chips. They are on pin 4, 7, 9 and 12. So we'll see on the scope what they look like. Okay, this is an output for the address multiplex chip, and we see almost full logic level. The low level is about 0 volts and the high level is more than 4 volts, so it's okay. This one is a bad signal. it is too low, not even 2 volts high. And you see the spike on transition, those are big current spike. That means this chip is trying to address is trying to drive a shorted line. So some of the RAM on this address are shorted, probably to ground. So we'll try to identify what chips are shorted to ground in this C64. Okay, I found that this chip has two probably shorted output, not inside itself maybe, but on what is driving. The pin 4 and pin 7, and pin 4 and pin 7 among the other things drive this chip on pin 4 and this one on pin 18. What I'm using is a current tracer, which is a nice tool that can show me where high current is. You see it lights when going over pin 4 and over pin 7, so it tells me that this chip is putting out a large current, and pin 4 of this one is getting this large current more likely, and also pin 18 of this one. So I'm going to remove this first and then this one and see if I can solve the short to ground. Okay, here we put a socket in the place of the probably bad chip, and let's have a look how signal are looking now. Okay, this is the signal that was not going over 2 volts now, and it's at 5 volts. So this chip is not driving short anymore. And let's check on the other pin that was driving a short. This is the 7, and you see a good signal also here. That's because probably this the current for this chip was shared for this pin. The current for this pin was shared with the current for the other pin, and removing the short on that pin cleaned the signal also on this pin. So let's put a good chip on this place and see what happens. Okay, new chip in place, and same result, but this time signal is still good. So there is another fault. Let's try to find a new one. This is the part of the diagram about the substituted chip. Actually, I had not really look at the very carefully, because the pin 4, as you see here, is an output, it's not an input. So it means that there's these two inputs, this one and the one from the other chip. Here we are. This chip and that one that we changed were driving their output at the same time, and they should not do that. Now the control signals are generated by this one, this chip, and this looks good. So what happens when two chips drive the same line at the same time? Probably they both have problems, so I need to change this one too, so we can exclude this one is faulty, because this one and the one we changed were driving the same line at the same time, so one of the two failed first probably. And both need to be changed. Okay, let's recap the situation on this one, because my SD card in the photo camera just died on me and I've lost some hours of videos. But anyway, we started on this one by checking U13, high current on some of the pins, and that current was coming or going to U14. Is this U14? Yes. So first I changed the U14, then I checked the diagram, and I discovered that U13 and U14 were driving at the same time the same address line, so I had to change also U13, because two chips that drive the same line fail, probably both. And actually I checked, they removed the chips on another C64 board and they were shot anyway. Then we had always blank screen, and going with the oscilloscope on the output of this one, U25, this is the U25, which is the twin of U13. I discovered that also this one was bad, because one output was not going to the full logic levels, so I changed also this one, but still blank screen. So next step was going with the logic probe on this one, which is an address decoder for the I/O chips. There's half of this one is decoding, is making the chip select for the SID, for the VIC, color RAM, and the other half, I'm going by memory, the other half is making the chip select for the two CIA, for example, and the other signal that are mapped into the I/O space of the CPU. And this one was the original one, this is the replacement, was faulty too. The first half, the one driving the SID and VIC was okay, fortunately, very fortunately. And the second half, driving the CIA, was shot. So the CIA were always selected and driving the data bus, so making a huge conflict on all data lines. That may have damaged both the CIA, their ROMs, and the CPU. But the situation after this change is this: almost there, almost. That means CPU is probably okay. Also RAM can be damaged by the data conflict with the output of the CIA. So CPU is probably okay, PLA is probably okay. So I tried with a cartridge and mostly the cartridge works, so probably RAM is okay. Probably RAM is okay, and probably, well, CPU is most likely okay, we said earlier. So probably it is either CIA, one of the two or both, or some ROM. So we need some checks, some further checks. This is the situation with the cartridge. It's loading or probably decompressing the program, and it mostly works. Graphics okay. So probably the RAM is okay also. Probably the RAM is okay. And CPU of course is okay. Probably also the PLA, but that was not affected by this problem because the PLA only works with the addresses, not the data bus. Data bus was the problem when you select more than one chip at a time. Data bus is driven by all the selected chips, so they conflict on the data lines. So probably is one of the ROMs, or and this two. So I will check when the cartridge is inserted which one of this is not used. Probably the basic. Probably this is the basic RAM. Sorry, the basic ROM. So probably this one is the one that I will change first. But I will check on the oscilloscope if this is used by the game. Probably not. Okay, we are going to test with the logic probe, which is a very good tool. What ROM is used? You see the cartridge is working, and ROM select is on pin 20, 24, 23, 20, 21, 20. So basic is not used. You see the steady light means high level, and the chip select is active low, so this ROM is not used. Check the kernel one. Okay, you see the flashing, so this is being used, is continuously selected, so probably the kernel ROM is okay. And this one is the character generation ROM. So this one is not used, but I would expect garbled characters if this was the problem, not a completely blank screen. So I'm going to change this one and we'll see what happens. Here we see socket, a new basic RAM, and welcome back. That was quite a failure. That was quite a failure. Now this is one of my ROM, so I'm gonna try one of the spare parts that Tony sent me, and then anyway I'm going to try to load the test program and see what tells me about the whole system now. Okay, program loaded. See what happens. Wow, we didn't lose anything else. That's great. Yeah. Okay, fine business. This one was quite a large failure of chips, and I believe that if they were normal TTL chips, I would suspect some power supply problem at one time. But all the chips that I changed were the MOS technology equivalents, like this one. This one survived, and most technology chips aren't famous to be reliable, so probably they failed at one time, and these two probably the first failing chips did the trick in getting also the other one to crash or go bad, because they drive the same address line but at different times. This one drives the line when the CPU wants to access RAM, and this one drives the address line when the VIC wants to access the RAM. This one had another kind of failure, so probably unrelated. It could have developed the failure even when the whole system was powered down. This one had a very catastrophic failure because it was continuously selecting the CIA, both of them, and so this failure made both the CIA to drive the data bus, and that probably made the basic RAM fail. That was amazing that no CIA failed, no kernel RAM, and no CPU failed. Also no RAM, because every access that the CPU made, these two guys were also answering and driving the data bus. So that's pretty good as a result that we had only to change the basic RAM after this kind of failure. So this was one of my favorite games back at the times. Let's see. I will play a bit and bye bye, see you next time. 94,000, not bad for playing with keyboard. Yeah, bye game.